Alright, the first problem we're doing is from 10.6. It's number 47, as you can see. And it is an airplane problem. So, first things first, we're going to draw our diagram. The plane flying in the direction of 200, again, that is referring from north. So we need to go 180 degrees plus another 20 degrees. And that is our heading. And the magnitude of that is 500. So I'll mark that as 200 degrees, 500 miles an hour. The second piece of information you're given, the course and ground speed, that is after wind has been taken into effect. Alright, so we're going to use blue. Blue is going to represent where the plane is actually going. Its course and ground speed are, like, on a radar, what would your blip be doing? Even though your plane is facing one direction and your speedometer says one thing, what a radar would actually show after taking into account what the wind has been doing to your airplane is given here, the 210 degrees at 450. So what we know here is, again, we've gone around 180, but then we need to go 30 more. So we're going to go like that. Maybe I'll just draw this little one. Again, this is just for visual purposes anyways. So, and that's 450. Now I should, if I draw this properly, I should actually draw that shorter, because again, the length of my arrow, or my line, does represent the magnitude. So because 450 is smaller, I should draw the line shorter. Now, essentially what we've been given, again, like I said in class, we have vector P, which represents the plane right here. We've got down here, let's go, I don't know, let's go orange for W. Okay, that's what we don't know. That's what it's asking. What is the direction and speed of the wind? And then blue is our vector P plus W. There we go. So in all of these, we end up with a cosine theta, and that's all the I hat of the vector, like the x component of the vector, plus, let me move this down here real quick. The b component of the vector. And actually, you know what? Instead of using A and B here, what I'm going to do is call these, let's go real thin here, magnitude of P there we go. So in order to create the vector P in its component form, the I hat and J hat components, we're going to have to do the magnitude of it times cosine theta and magnitude sine theta. Well, the magnitude is easy. The magnitude is the speed of the airplane. It's the theta that's going to be tricky. So let's go back to medium. And P is in our black, and actually we should probably change that. Be red. So instead of giving the direction 200 degrees from north, a vector always starts from the positive x-axis. So I'm going to do that in black. I'm going to call that right here. This angle here is the theta for P. And we'll go light purple then. Even bigger. That is our theta for the vector P plus W. So the first thing we're going to do is find theta P and theta P plus W. We'll go down here and do that. Theta for the plane. Well, we know that from here, if you can follow just the cursor, we've gone around a full 180 and then 270. But then we're going to take back these 20 degrees. So again, we're going to start at the positive x-axis, go around 270, but then we know that we have to backtrack 20 degrees, which is 250. Again, from the positive x-axis. While we're at it then, we'll do theta of P plus W. And actually that's really close to theta of P. We're going to go all the way around again, from 0 to 270. We're going to come back the 20 degrees to P, but then there was actually another 10 degrees here, so it's 270 minus 30, or 240. Just so we're clear on that, we know that the direction was 200, so if we go around 180 from north, that's how I'm getting the 20 degrees here. And 210 degrees means from due north, I go 180 plus 30. But I'm going to break it into components. 20 degrees from there and only 10 degrees there. Nonetheless, we have our theta P, so we can go ahead and take this equation for our vector P. Magnitude of P, again, is just the speed, 500, times cosine of theta. Our theta was 250. That's our I hat component. Squeeze that all in there. So, vector P is magnitude times cosine of theta plus magnitude sine theta. The wind we don't know, but our course and ground speed given the P plus W is, again, that's 450 cosine of its theta, which is 240. There we go. And we'll close that in as our I hat component, like our horizontal component, plus the 450 sine 240 j hat. So what do we know about W? Well, if we take the vector P plus W and we subtract P from it, we get our vector W. So that's what we have to do. We have to take the I component of P plus W minus the I component of P, and we'll get our resulting wind vector, I component. Then we'll take our J component of P plus W minus the J component of just the P, and we get the J component of just the W. So, easier said than done, right? It's just a lot of writing, so real quickly, we'll do that. Not sure what just happened. Okay. I'll refill that in. Minus P gives us W. So what does that look like? I'll still try and color code it. We've got Oh, I'm sorry. The p plus w minus p, so that's 450 cosine 240 minus 500 cosine of 250, and that is our I hat component. The p plus w minus the p, plus the j hat component. You could even bracket that in. Our j hat components are 450 sine 240 minus 500 sine 250. Get all of our ducks in a row here. From there, it's a matter of just plug and chug. Plug in your calculator, cosine 240, multiply by 450, so on and so forth, and what you end up with is the w equals negative 53 plus 80 and the I hat j hat. So that is our resulting vector. That's great. We've got the math down. We still haven't answered the question. The question says, what is the direction and speed of the wind? Well, all we have is the location of the end point of our vector w. So what we have to do to find our speed and direction, well, our wind speed for this is going to be the magnitude of w. So we're going to take the square root of, and this is very rudimentary here, very basic, wow, or squared, and you find the square root of both numbers squared. Take the square root. Let's see, that is about 96.63 miles per hour. So we at least have one component of our answer, 96 miles an hour. The direction. Now the direction, the easiest way to do this direction part is remap out. We're going to go negative 53 up 80. So this is our 53 component. Here's our 80 component. Okay, there's the vector for our wind. Now, when you put it back up into this, that little orange component is going to be somewhere, turn it orange, somewhere like this. And it's not going to be very big because these other vectors are 500 and 450, and we're only dealing with somewhere around 96. So again, we're just going to find this theta. Actually, I'm going to call it alpha. Alpha is tangent inverse of the 80 over the 53. And to find the actual direction, theta, of w, well, let's see. Our vector puts us here. The direction itself is going to be from north. So I have to go 180, 270, 270 plus alpha. So 270 plus alpha. And let's do some number crunching here. So let's see, our alpha was 56 degrees. So our theta is 326. Again, that's approximate, but about 326 degrees. So these two answers here, our speed and direction of our wind, are the final answers on problem 47. So as a really quick recap, you end up from north, you go 200 degrees for the plane. From north, you go 210 degrees for the wind. And then you have to convert those 200 and 210 into vector angles, theta. Once you get that, your vector p is magnitude, which is your speed. Speed times cosine theta plus speed sine theta. Same thing for your resulting p plus w. And then what we ended up doing was taking the p plus w vector minus the p vector, the two that we were given, and we found our wind speed vector. And crunch your numbers, and there you have it.